Okay, now we've got the basics with surds. Let's have a little bit more fun. We'll start back at the easy stuff. We're going to simplify root 18. 18 is 9 times 2, so it's root 9 times root 2. Remember, we can split that there, which is 3 root 2. So the next question says, rearrange 3 root 2 to the form root a. So that's the exact reverse process of what we just did. So we want to go, well, okay, so we're going to start with 3 times root 2, because that's 3 root 2. We're going to replace 3 with, well, what is 3? Well, root 9 is 3, so we still haven't changed anything. That's 3 multiplied by root 2. And then we're going to merge our radicals, which is root 18. So because we can split them, we can also merge them that way. So we need to be able to go both ways. Calculate root 2 times root 3. Well, remember, we can merge our radicals, which is root 6. How easy is that? Root 5 times root 10. Clearly you can see that that's root 50. Is that our answer? No, because root 50 can be simplified to... So be careful, just because we can do some simple combining under that radical doesn't mean that that's all we need to do. We need to be able to check our answer every single time, and we want to display our answer in simplest form. The way I'm seeing that is 2 times root 3 times 3 times root 6, which is 2 times 3 times root 3 times root 6. I'm just putting them in a different order. 2 3s are 6. 3 times 6 is 6 root 18. Yes, I haven't stopped there, but we're getting like big boy pants here, big boy and girl pants. So do we need all of that working? Probably not. So I'm good for you to go 2 3s are 6, and root 3 times root 6 is root 18. Okay, then yes, I hear someone saying, hey, root 18 can be simplified. Root 18 is 9 times 2. Root 9 is 3. 3 times 6. So what's that? 18 root 2. Okay. You know how we've been putting that under the 1 because it's a multiply by sign. Sort of stands to reason that a divide by sign will work the same. So we can go root, we can combine that root radical to do that, which is just root 5. We can do this one, that's 6 times root 14 on 2 times root 7. What we're going to do is we're going to... What's going on there? Let's just go back. That's interesting. Okay, that jumped up there. Okay. 6 on 2 multiplied by, let's just join that radical. 14 on 7. Well, 6 on 2 simplifies to 3, and 14 on 7 simplifies to 2. 3 root 2. Well, That paid us a visit before, didn't it? Anyway, okay, so let's go. 15 and 3 cancels to 5. So it's going to be 5 root 24 on 6. What's 24 on 6? 6. 4s are 24. What's root 4? Root 4 is 2. 2 times 5 is 10. So that one there actually just comes to a real number, which is okay. I've got no problem with that. It is what it is. We had that one before. This is getting interesting, isn't it? Okay. Let's do this one. The 10 and the 2 cancels to 5. So it's going to be 5 root 8. And see root 8? Root 8 is 4 times 2, which is, root 4 is 2. 2 5s are 10. So you can see it's all pretty easy, but there's so many different ways that we can play with surds. We are going to expand. Root 2 times root 3 is just root 6. Root 2 times 1 is. Are they like terms? Can I simplify it? No, so that's our answer. Expand. So that's root 18 plus root 6. Is that our answer? You're right. No, it's not, because of that 18. Root 18 is 9 times 2. We're going to split that. Root 9 is 3. Always look for your simplification. Expand, calculate, okay. We know our patterns, a plus b squared is a squared. Well, root 5 squared is just 5 plus 2ab, so it's going to be 2 times root 5 times 1, which is just 2 root 5, plus b squared, which is 1. Expansion patterns, got to know them. A minus b all squared. So here we go. A squared. So when we're squaring 2 root 3, we're squaring the 2 and we're squaring the 3. The 2 squared is 4 and the root 3 squared is 3. 4 3s are 12. Thank you. Get off there. Okay. So 2 root 3 squared is going to be 4 times 3 minus 2 times that, which is 4 root 3 root 6 plus root 6 squared, which is just 6. 4 3s are 12. 12 and 6, 18 minus 4 root 18. And you're right, that 18 is I'm running out of room, sorry about that. So it's 18 minus, that's going to be a 3. 3 4s are 12 root 2. Whew. Okay, so this is an important expansion. This is a plus b, a minus b, which is going to be a difference of 2 squares. You can see we're going to do it again down there. Okay, so a plus b, a minus b will just be a squared minus b squared. So a squared is 2, and we're going to subtract b squared. 3 squared is 9, so that's going to be -7, just a number. which stands to reason because in our answer all we've got is two numbers that are squared. Well, we're dealing with surds, so that undoes the surd. This is another one. That's a plus b, a minus b, and we're going to go to a squared, which is 5, minus b squared, which is 3, which is 2. The fact that we're ending up with just a number is really important. This relationship here is called a conjugate, if I can spell. It's a J. Conjugate. These two things here are conjugates. That and that, they're different, but they're conjugates. They've got a special relationship, and that relationship is it gets rid of anything that looks like a surd. Oh, last one. Let's find the area of that rectangle. So area equals length times width. The length is 6 plus root 8, and we're going to multiply by root 8. Well, I want the root 8 at the front because that's easier to go. Root 8 times 6 is 6 root 8. Root 8 times root 8 is just 8. Let's simplify that. 8 is 4 times 2. That's going to be 2. 12 root 2 plus 8. That's a bit messy. Okay, have some fun playing with surds.